Welcome to our presentation on Chapter 17, Concurrency. Just the usual reminder, our next class will be in 2 weeks' time on networking. At the same time, and I will send out a notice. I notice our numbers are down a bit tonight. Presumably the rest of the class has been load-shedded or they're working diligently on their assignment, which many students haven't submitted yet. Before I get going with concurrency, I just want to go through a few aspects of assignment 2. I'll get there eventually. Okay, assignment 2, there's just a few points, largely feedback from assignment 1. But if there's any questions you want to ask about assignment 2, please do. Okay, these are in fairly random order. I just noted them as I became aware of them. The first thing, please do not use Qt Designer at all. If there's a form or any UI pointers in your submission, you will lose marks. Several students submitted assignments with either used Qt Designer outright or there were UI pointers all over the place and they lost marks. Next thing, you must use QMake, not CMake. We had a few students submitting assignments with CMake. Another thing, you must have a main CPP file. Do not include the main function in any other file. Just makes it more difficult to mark and use your application. And then another one which I thought everyone would know by now. Please, it's one class, one responsibility, one file. And when I say one file, I mean the header and the source file together. Do not put multiple classes into one set of files. Each class must go in its own separate file. Then forward declarations, use them where possible, but a big no-no, please don't include large libraries in your header file. It makes your application much bigger than it needs to be. Then do not use these large libraries like Qt GUI or Qt widgets. They're very big, and if you're only using 2 or 3 widgets or very small parts of the GUI, just include the individual classes. Don't put these big includes all libraries. You're adding a massive overhead that doesn't give you any advantage. And this next thing was probably the biggest single set of errors. Initialization of class members must be done in the initialization section of the constructor. Please not in the body of the constructor or not in other methods. We had quite a few students submitting assignments with initialization of class members all over the place, spread over 2, 3, or 4 methods. It makes it very difficult to see what's going on. It makes your code quite messy. Put all your initialization of class members in the initialization section of the constructor where it's supposed to be. And also do not use initialization by assignment similar to this example, because then you're calling the default constructor and then you're immediately calling the copy constructor, and that's double the processing. Use initialization by means of a constructor, by passing the argument to the constructor the way it should be. Don't do default initialization and then call the copy constructor straight afterwards. Laying out of code neatly using indentation and black lines. Okay, a lot of you got that right, but surprisingly quite a few didn't. And we just got sort of blocks of code, sort of 20, 30 lines deep with no indentation or no blank lines in between them. It makes it very difficult to read when you've just got a sort of a blur of code with no break or anything in it. Then feedback, very few use tooltips and placeholders and the like. That's something you need to fix up a bit for assignment 2. And then validation. A lot of students just ignore this completely. I know it doesn't specifically say you need to validate. You don't necessarily have to do the whole thing with validators and regular expressions, but you must do basic input checks that input strings aren't just blank, or that somebody doesn't just push the submit button and all the inputs are blank or something like that. So you must at least do basic validation. Don't just allow, for example, blank input and then try and write things to file that is just blank, or try and process things that are all blank. You must do at least some basic validation. And another area where a few students run into problems, in general, you don't really ever need to use anything else than Q widget for your main window. You don't need to use Q main window unless you really want to use menus and status bars and toolbars and things. A Q main window is just a Q widget with added functionality. If you're not using that added functionality, don't use a Q main window. Again, don't use Q dialog as your main window unless you actually want a modal pop-up dialog. Q label as well, it's got limitations. It's okay for very small GUIs, but in general, you shouldn't really have to use anything other than Q widget for your main window. And then how to submit your assignment. These instructions are readily available. Please, you must put each question into a separate folder, and you must only include your header and source files and the project profile. Don't include any executable files or object files, and that it makes your submission very big. And when you've got 400 odd to download, it makes a massive big download file if there's build files all over the place. So please only submit your header and source files and the profile. And if you really have to, a README file. But put each question in a separate folder and then zip it. And that's what you submit. Please, as I said, we had students submitting all kinds of rubbish in amongst their files, and Word files with screenshots and multiple questions in one folder and things like that. Please make sure you follow the instructions. They are available on my Unisa, and I'm pretty sure they're in one of the tutorial letters as well. Okay, while we're here, are there any questions on assignment 2 that anybody needs clarification on? There's still about 300 students who have to submit assignment 2, so I presume a lot of you are not proceeding as rapidly as hoped or expected. But if you need any clarification, now's your chance.
Hi, can I ask a question?
Yes.
The email that you sent this week earlier, it was very confusing. So when is the assignment actually due?
The assignment was actually due on Monday, the 11th of July at midday. There is a grace period of 5 days, and submissions will be accepted until Saturday, 16 July midnight.
So Saturday night, not Saturday morning?
No, Saturday midnight, 2400.
So Friday night?
No, Saturday night. Midnight on Saturday. End of Saturday.
Okay, thank you.
Okay, Linda, okay, when you remember your question, ask it. Question from Joel, can you give us any hints on when to use open versus execute versus show? Generally, when you use a widget, you show it, and when you're using a dialog, you execute it. Execute is generally a modal display, where show is just a normal display, but it depends on what widget you're using, when to use those. There's no absolute exact answer. Generally for Q widget, you show, and a dialog, you execute. Okay, any other questions? Any clarification on the questions in assignment 2?
So I sort of remember my question now, sir. So
okay.
In question 3, when you have to use, all 4 buttons to call a single, like a single function that however you sort.
Slot.
Yeah. So are you allowed to use the sender function? So basically, as I type like this.
I would actively encourage you to use the sender.
Okay, so that worked perfect.
method
I
of
was
project.
just making sure that, you know, like, are we allowed to actually over-engineer it? Because I know
That's
obviously
not over-engineering, that's the basic way to do it.
okay.
If
That's
you
fine.
want to complicate things, you can use Q-signal mapper, but it doesn't achieve anything more, and it's just the extra class in your application.
That's fine. Load shedding really makes my life difficult. I don't want to make it any worse. Thank you, sir.
Okay. Now, sender would be the normal way of doing it. Okay, is that it?
I have another question.
Yeah.
Yes, sorry. It's about the first question in assignment 2.
Yes.
We were asked to use one regular expression for finding
Yes.
start and the end tags.
And the break tag, yes.
So,
I mean, the empty element tag, yeah.
yes. So I was able to find the start and end tag using forward lookup. So starting from the start tag, and then looking if there's an end tag that matches with that specific word. But I realized that basically in Qt, the regular expressions that they're using, you can't do backward. You can't look backwards, basically.
You can do in Qt with regular expressions anything you can do anywhere else. They're no different.
Because I got some limitations with finding an end tag that.
Okay, well, let me just maybe answer your question in a different way. I went through this in the previous meeting, and I said something along the lines that answering question 1 is a 2-part process. Use a regular expression, and I emphasize a regular expression, to identify all the tags in the file and draw them out. Once you have them in some kind of a list or iterator, then you can just use normal string and string list manipulation to find matches and unmatched pairs and so on.
Oh, okay.
For that part, you could actually use regular expressions. There you'd need to use separate regular expressions to identify matched and unmatched tags, but it's not necessary. The first, you use your regular expression to identify and extract all your tags. And then once you've got basically a list or iterator of tags, then you can just use string list and string methods to manipulate them and compare them.
Oh, okay. I thought we were supposed to use one regular expression.
Now it says to identify the tags in the file.
Oh, okay. Then no, that makes sense.
It doesn't say you have to use that for the further processing as well.
Oh, okay. I guess that's where my confusion was, but thank you.
Okay, anything else? Okay, well then we'll move on with concurrency. Okay, so everyone happily coding along with assignment 2, because I've seen some weird and wonderful approaches to some of the questions. But if you think of any other questions later on or towards the end, you can feel free to ask them. Right, let's get on with concurrency. Okay, what you need to know for this part of the syllabus, you need to know the different classes in Qt for implementing concurrency. That's mainly QThread and QProcess. Understand and implement multiprocessing using QProcess class, and understand and implement multi-threading using the QThread class. Then you also need to know about some of the related aspects. That's about thread safety and the classes available in Qt for thread safety. Because when you're using multiple threads, you must make sure you don't have clashes with regard to resources and have multiple threads all trying to access the same resource at the same time. Okay, in general, concurrency is the fact of 2 or more events or circumstances happening or existing at the same time. Notice the happening or the existing. There's some subtle differences here when you look at it in more detail. Okay, then more specifically, concurrency is a condition that exists when during a given period of time, and notice this, a period of time, at least 2 threads are making progress. So it's in a period of time, it's not a point of time. So concurrency, it's a condition that exists when during a given period of time, at least two threads are making progress. It doesn't mean that they're both making progress at the exact same point in time. It's over a period of time. Then concurrency is a property of a program. It affects the program structure. And concurrency can occur in a single core processor through time slicing, right? That's where the processor allows one thread to run, and then it stops that one, and then allows another one to run, and then stops that one, and then allows another one to run. So technically, they're not all running at the same instant or same point of time, but over a period of time, they're all making progress, and that is concurrency. So please be aware of that distinction. Concurrency occurs over a period of time, not a point of time. And there's another concept called parallelism, which you don't need to know about for this module. I'm just mentioning it because you will see it in various sources. Is a condition that arises when given a particular point of time. Now, this is a point of time as opposed to a period of time. At least two threads are executing simultaneously. And this is a runtime behavior as opposed to a structure element as for concurrency. And it affects program execution. And you can't have parallelism in a single core processor. For parallelism, you've got to have multi-core processors so that you can have multiple processes running at the same point of time. So that's just the distinction between concurrency and parallelism. As I'm just mentioning the parallelism thing out of interest because you will see it from time to time. But what you need to know for this module is about concurrency and this distinction about concurrency occurring over a period of time and not necessarily a point of time. So that's briefly what concurrency is. And there's two approaches to concurrency. The one is processes, which is an executing instance of a program, or in Windows, it's referred to as a task. And a thread is an executing unit that are part of a process. So a thread is basically a subset of a process. All your threads execute within a process. So that's quite a big distinction between the two. Then looking at a bit of a comparison between the two of them, right? A process, as I just said, is an executing instance of a program or a task. And each process has at least one thread, and a process can consist of multiple threads. And then a process also runs in its own memory space. In contrast to that, a thread is a functionality within a process, in other words, a subset of a process. And threads run in a shared memory space. They use the memory of the process they belong to. So if you have multiple threads, they're all running in a shared memory space, and that memory is part of the process that they belong to. And carrying on, a process has its own resources, its own memory space, files, etc. Whereas threads share the process resources, and as we said, they run in the same memory space. Then process communication between processes is more difficult and resource intensive. That's because they are completely independent, basically. And threads have relatively easy communication between threads for the simple reason that they are sharing memory space. Now, this thing about communication between processes being more difficult, sorry, excuse me, I've got a bit of a cold. That is, in fact, more or less invisible to you as a user of Qt, because Qt actually handles all of that for you. So from a user point of view, programmer point of view, there's no real difference in the level of difficulty between threads and processes because Qt is handling it for you. But just bear in mind when you do have communication between processes, there's a lot more going on under the hood than with threads. But it's not something you need to worry about too much. So Qt handles all of that for you. So that's briefly the difference between a process and a thread. Basically, a thread is a functionality within a process. In other words, a subset of a process. and it shares memory, whereas processes run each of their own memory space. So that briefly is the distinction between a process and a thread. Okay, then looking at Q process, which is Qt's implementation of process. Right, Q process is the class for running and controlling other processes. It's derived from Q object. So it uses signals and slots, or that's what enables it to use signals and slots. And that's how you can communicate between processes, is just using signals and slots. So it's not really different from any of the other communication you've been doing. Right, Q process launches another process using its start method, and it takes the program name as an argument, and you can pass the string list of arguments which the program will execute on startup. Those are command line arguments that you can pass to it. And this new process is a child process that terminates when the parent process terminates. That's the normal course of events if you use start, but there is an alternative called start detached, and that starts a process that continues running after the parent terminates. So that's quite an important distinction. When you use processes, you need to decide if you just want to use start so that it has the same life cycle as its parent, or if you use start detached, in which case the process can continue running after its parent terminates. And then as alternatives to using passing those arguments to the start method, you can actually set them individually. There's a set program and a set arguments method, and then just call start without arguments. Start is obviously overloaded. So you can call the start method and pass it a program name and its command line arguments, or you can set the program, set the arguments, and then call the start method. Now, just something to be careful of, the way threads and processes are handled in the prescribed book is, well, to put it bluntly, pretty wrong. You will very rarely, if ever, need to subclass Q process. You only need to do if you want to extend the functionality, for example, add a specific signal. But in the normal course of events, you will never need to subclass Q process. You just want to run another program as a process. So don't pay too much attention to the examples in the prescribed book, rather look at the Qt documentation. To be fair, the methodologies that are shown in the prescribed book were correct at the time the book was published, but Qt has moved on, and the way it has done things, particularly with threads, as we see when we get there, changed quite dramatically over the years. It's a case of what's in the prescribed book is now outdated. It's been superseded by events. But don't pay too much, or in fact, don't pay any attention to the examples in the book about Q process and Q thread. Excuse me. Okay, then some of the methods, I'm not going to go through all of these in detail. You can look at them in the documentation. I'm just going to point out the ones that you need to know about. As I've already mentioned, the start method, that's the one you will use most often. That's what you use to start a process. And you can use it like this, passing arguments, or by setting those arguments separately. And there's start attached, which starts a program that will outlive its parent. And there's other things you can do, like set the working directory. If you want your process to run in a different directory, it doesn't have to run, for example, in the current directory. As noted here, the default behavior to start the process in the working directory of the calling process. So you can set working directory to make your process run somewhere else. And then I've already mentioned set program and set arguments. So Q process is basically pretty simple. It just allows you to run another executable file from within your application. It's not very difficult to use. There is an example in the exercises, which I hope you're all diligently doing. Otherwise, you will find other examples in the QT documentation and elsewhere. I'd suggest you do a couple of them, but you'll find Q process is actually quite straightforward to handle. Okay, then some of the other methods. These ones are quite important for now for communication. This one, read all standard output. That returns all data available from the standard output of the process. It comes as a byte array, which is easy to convert to a Q string. So that's how you communicate from your process back to its parent. You use this read all standard output. There's also one read all standard error, which I suppose you should always cater for possible errors. And then there's various other ones. I'm not going to go into them. For handling your error handling, there's error and exit code and exit status, which are all ways of, well, as the name suggests, checking the status and the exit code. Remember, exit code convention is 0, indicates no error. If you want to program other error codes into your app that you use for a process, you can do that, and then you can get information about how the app terminated or how it behaved by using things like the exit code. And then the one other one that's of interest is the state, which returns the current state of the process. It uses the enum, which is not running, starting, or running. So if you need to find out or get information of what the state of your process is it actually running, or is it not running, or is it still busy starting up? You can use that, for example, when you set up a process, if you want to give feedback, you can, when you get a message saying it's starting, you can then display to the user, the process is starting, and when it starts actually running, you can display a message, right? Process has started running, something like that. So this method allows you to give some form of feedback and also to check on the state of your process. It's often useful to make sure that it is actually running and that it hasn't stopped for some reason. Because if you might want to pass it some data and you don't see anything happening, it's probably worthwhile to actually make sure that it is actually running, for example. But anyway, these are the kind of methods you need to look at for Q process. So please look at the examples. But things like read all standard output is something that you will use often if you want communication from your process back to its parent. And an important part of Q process is signals and slots. Let's say you won't use all of these. There's ones like error occurred and then finished, which might be useful. That's omitted when the process finishes, and that also allows you to get the exit code and the exit status. One that you will use is ready read standard output. So whenever your process has some output available, it will emit the signal ready read standard output. And I'm just going to go back a page, and you connect, use this one here, the read all standard output method, to actually read that standard output. So within your process, you would use this ready read standard output. That's just the process is just saying that it's got some output available, and you must start reading it. And it's got a started method, which is the method when the process has started, i.e. when the state returns running. It's got a state change signal, which again, it's useful depending on how much feedback and so on you want to do. And then there's slots like kill and terminate. If you, for some reason, you want to get your process to stop running immediately. But as I say, it's best to do an example and connect up these signals and slots, the ready read signals and slots, and ready read and so on. You'll see the communication is actually quite easy. Any questions so far? Yes, Linda?
Sorry, so it's not specifically about this, it's about assignment 2. Is it okay if I ask that?
Yes, otherwise you're going to forget it again.
Yeah, literally. So I coded 2 buttons for question 2 to save and load the XML, and then I went back and I read again. I read it must load the file on start, and when you
Yes.
close, it must write it. So there was this one function where if you put it in, if you just put like to call your function in your constructor in your setup GUI and your destructor, it basically it works, but what if you don't specify a file? What if you open it, I just want to close it, and you click cancel? That kind of bugs out. So what I did was I wrote an if statement that says if this gets closed forcefully and it doesn't pick up a file, it'll do a exit failure. Is that fine, or is that like, because I'm forcing it to close? Because if you cancel, then it shouldn't continue loading the setup, but it does if you don't forcefully cancel it.
No, if you code it correctly, it won't. When you press cancel, the file dialog returns a null. So if you check for null, then you can handle it.
So I did do a check for null, and sorry, I don't want to keep up the whole class for this. I did do a check for null, and then I did a QApp. I think it's QApp pointer close.
You just say if result is equal to null, then depending on which way you want it, either quit or just carry on as before. Ignore the.
Okay, so if
you can
click
determine
no.
what happens. You don't have to force anything.
Okay, so we won't really get penalized if we let the program continue, even though you didn't specify a file. We're not going to get penalized for that then.
Yeah, you just say, you can just put a message saying no file read. You know, if a user doesn't want to read a file, you don't have to force them.
Okay, that's fine. Okay, thank you.
But there is one thing wrong with it. Destructor is not a good place for it. There's a close event that you should be using to capture the close event.
I wasn't happy with the destructor as well. I thought it was like this is the easiest way, but I said this can't be right. There must be another way of doing this.
A destructor is for destroying things. It's not for handling user input and output and stuff.
Okay.
So put it in the close event. That's where it belongs.
Yeah, thank you.
Okay, you can put your hand down unless you have another question. Right, a queue process example. Okay, an important part of using queue process is connecting your signals and slots. So in this example, we have a pointer to a process. I haven't shown that separately here. So you've instantiated a queue process object here called process. And you connect your processes, ready, read, standard output, to some slot in your application called process output. You then connect your process started signal, and you can have a slot within your application called process started, which would either do some kind of a processing or just communicate with the user that the process has started. You can connect your process finish signal, and you can give it an integer argument, which you can use for error status and things. And then you can have a slot called process finish to do some kind of a handling, depending on what the value of that integer is. And then error handling, which you should always do, connect your process error occurred signal to a process error slot in your application. Sorry, I did this a while ago. We're still using the old syntax here, but you can use the new syntax as well. So that's just an idea of what the kind of signals and slots that you need to use with your queue process. And if we look at some of them, we have a slot here. So if you've got a button in your view that you want to use to start your process, we have the slot here called start process, and then you just call the start method of your process. And that presumes that we've got an executable file available called random numbers. Then we've got a a process output slot which is connected to the ready read standard output signal, and this is, you would then use the read all standard output method, and that would allow you to receive the output from the process in your main application, and in this case I've just appended it to an edit view. So just to go again, this process output is a slot which is connected to the ready read standard output signal of your process, and then you just use that to read all the standard output that comes from your process. And then an example here of the process started. Remember, the process signal started is connected to a slot called process started. All I've done there is display a message to say that the process has started. So, oops. So using a queue process is actually quite straightforward. As usual, the best way to do it is just to do an example, get it running. The most tricky part is probably this connecting the signals and slots. But once you grasp it, it's not at all difficult to do. As processes are relatively easy. Okay, before we go on to threading, sorry, there's another question. Yes, Joel has pointed out that as you've done the exercises, you would have used the close event already, so that should be straightforward for you to do. Okay, queue thread. Okay, threading is a bit more difficult. In fact, it's a lot more difficult than using a process, and for some reason, a lot of students often struggle with threads for some reason. But the queue thread class provides a platform independent way to manage threads. And just some background, modern CPUs have multiple cores, and single-threaded applications can only make use of one core. So if you have an application with multiple threads, those threads can be assigned to multiple cores. And then obviously distributing work to multiple threads that use multiple cores can allow applications to run much faster. I hope that's fairly obvious. Then a queue thread object manages one thread of control within a program. So your queue thread object manages a thread. Just to be clear on something, queue thread is not actually the thread itself. It is actually a thread manager. The queue thread manages the thread. It's not the thread itself. So just bear that distinction in mind. When queue threads begin executing, they have a run method, and that's basically internal. But when you call the start method on your queue thread, that calls that run slot in the thread. So that happens internally. The one you will use is start. Okay, you don't need to worry about the next part. Okay, then moving a bit on with thread. Right, remember, as I said before, each process has at least one thread, which is known as the main thread. It's also referred to as the GUI thread. And please note in Qt, the GUI must be in the main thread. You cannot move your GUI to another thread. Your program will crash. That is the one stipulation. The GUI must remain in the main thread, as it's often called the GUI thread. Then QThread emits signals when the thread is started and finished and so on. Or you can use these methods like isFinished and isRunning to query the state of the thread. You can also stop a thread by calling exit or quit. In extreme cases, you may want to forcibly terminate an executing thread. However, doing so is dangerous and discouraged. It actually says that in the documentation. So, of course, one will always wonder why they have a terminate method if it is dangerous to use it and its use is discouraged. So the short answer is there is a terminate method, but don't actually ever use it. And then a very useful aspect of it, and I'll be showing you a coded example shortly. It is possible to deallocate objects that live in a thread that has just ended by connecting its finished signal to the queue object delete later, and that handles the calling delete on your pointers. So if you connect your thread's finish signal to queue object delete later slot, the pointer aspect will be handled for you, and as I'll show you an example of that surely. Sorry, Tati has arrived and she's wants some attention. Okay, Hannah's question, what is the purpose of queue process? Queue process is to run a process from within your current application. So from within your current application, if you want to run a different separate application, you use queue process. It basically allows you to run another program from within the program. Just a kind of example, when you're using Windows and you use the calculator, for example, that's a process. It's a separate program that pops up as a calculator. But yeah, it's when you run another program within a program. Okay, and some of the methods you'll be using with QThread. This is a very important one, is move to thread. It changes the thread affinity for the object and its children. A very important point, an object cannot be moved if it has a parent. So you can't use QThreads if the object has a parent. That's very important. Please note that it's a mistake that happens from time to time. So you can move an object to a different thread, and that its processing will then continue in the new thread. So you start an object in one thread, then you use this move to thread method to move it into another thread. And that is basically how you implement multi-threading. Okay, then it has a thread method which returns the thread in which the object lives. Okay, you don't use that one very often. Then it has an exit method which tells the thread's event loop to exit with a return code. Again, convention is return code of 0 successful, anything else is some kind of an error. So you can, if you want to start adding in your own event codes, if you want to find out information about how your thread progressed. Then it has an is finished method which returns true if the thread is finished, otherwise false. As it's useful to be able to use methods like is finished and is running to find out the state of your thread. It might be important before you do any further processing to know if your thread has actually finished already, or to find out if it is actually running or not. So those are methods that are useful. Then another interesting one here is ideal thread count. It's got a slightly unusual name. And that returns the number of processor cores that are available in your computer. Please note, and I don't quite honestly fully grasp this part of it, but they're not necessarily all real cores. They include real and logical. Those of you who know more about hardware can probably decipher that. But this is quite a useful method, ideal thread count. If you want to split an application into multiple cores, it's no good trying to implement more threads than you have cores available. I think quite a lot of computers nowadays have at least 4. So you would need to find the ideal thread count first, and then try and say start 6 different threads if you've only got 4 cores available. So that's quite an important method to use. More methods about thread. I'm not going to go into the detail of these. You don't actually use them very often. There's one called execute and there's one called run. Please look at the QThread documentation. You don't really use these ones very often, but if you want to know more about them, have a look at that. I actually want to get onto the coding part of this. Okay, and there's some slots available which you will use. QThread has a quit slot. It tells the thread's event loop to exit with return code 0. In other words, successful. That's equivalent to calling QThread exit with a 0 code. It doesn't do anything if the thread does not have an event loop, which wouldn't normally be the case. And an important one is qthread start, right? That begins the execution of the thread. And as I said, internally, that then calls its run method, but you only have to worry about the start. And then terminates the execution of the thread. Note the warning is dangerous and use is discouraged. Don't actually use it, but you will see it in the documentation. But as it says in the documentation, use this method only if absolutely necessary. Rather don't use it at all. Then signals, as you see, these are quite similar to queue process. There's a finished signal and a started signal. An important slot is this delete later. Delete later, that schedules it for deletion when it's no longer used, and that handles all the deletion of the pointers. So that's a very important one, and one that you will need to use. As I will show you the example now. Sorry, excuse me. Okay, thread safety. This is something you need to know about. You need to know the difference between re-entrant and thread safe, which can be a bit confusing at times. But an application or code is thread safe if it behaves correctly when accessed from multiple threads. So when you start using multiple threads, things can get a bit tricky, and your potential for causing mega crashes increases quite steadily. So some of the issues that you might have with regard to thread safety is trying to access shared data without locking it. In other words, if you get two or more threads trying to access the same resource at the same time, you get what is known as a deadlock when threads 1 and 2 both need access to A and B, but thread 1 locks A and thread 2 locks B. Then they both sit there waiting for each other, and neither can proceed. Then you also get what's known as a race condition, which is behavior dependent on the timing or sequence of events. It may be unpredictable in a multi-threaded situation. In other words, if you get one thread that you would expect to be completed before another one, but for some reason that thread slows down and the other one speeds up, they might finish in a sequence that you didn't quite predict or would be unusual. You cannot always expect that your threads will progress at the same or similar rate, and you might get situations where one goes much more slowly or another one finishes early and things like that. So just be careful of potential race conditions. You need to just be able to handle unusual sequences in your code. Just don't assume that everything is always going to go exactly as you hope it does. Right, then this concept of re-entrant. So if execution can be interrupted at any point and then safely called again, in other words, re-entered, that's where the name comes from, then this is known as being re-entrant. And there's a word invocation, that's a call. We talk about calling a function or invoking a function. So a function is re-entrant if it can be called simultaneously from multiple threads, but only if each invocation uses its own data. And a class is re-entrant if its member methods can be called safely from multiple threads, as long as each thread uses a different instance of the class. So re-entrant is like a lower form of thread safety. It's situations where they are safe, but there are limitations. And the limitation for function is only if each function uses its own data, and for class, as long as each thread uses a different instance of the class. And we'll compare this now to what's thread safety, but just remember, re-entrant is basically a lower form. It's thread safety with limitations. If you look at thread safe itself, a function is thread safe if it can be called simultaneously from multiple threads, even when the invocations use shared data. So it's re-entrant if they use separate data, but if they're using shared data and it's safe, then it's thread safe. A class is thread safe if its member methods can be called safely from multiple threads, even if all the threads use the same instance of the class. Remember, re-entrant is different instances of the class. So thread safe is basically the full thing, basically safe under all circumstances. Re-entrant is safe with limitations. Then moving on to other concepts that we will get to, or that you'll be required to use, there's Q-mutex, which is a basic class for enforcing mutual exclusion. A thread locks a mutex in order to gain access to a shared resource. If a second thread tries to lock the mutex while it is already locked, the second thread will be put to sleep until the first thread completes its task and unlocks the mutex. Right, so this is one way of enforcing thread safety. The first one to get there implements what's known as a mutex. It basically locks access to any other threads, and then it only unlocks it once it's finished processing and moves on. So using a Q-mutex is one way of ensuring thread safety. Then you also get a Q-read-write lock, which is similar to a mutex, except that it distinguishes between reading and writing. Right, a mutex basically locks it completely, whereas a read-write lock, you can lock it for reading or writing. So it gives you better control. It's not just a total block. You can still allow some access. And then you have what's known as a Q semaphore that protects multiple resources. A mutex protects one resource only. But these mutex and semaphore and Q read write lock are things you should be familiar with. So look at the documentation. Then there is something known as Qt concurrent, which is a high-level API for all this concurrency and stuff. We don't use it in this module, so don't look at Qt concurrent or look at it for interest, but you can't use Qt concurrent in any of your assignments, and you won't be examined on Qt concurrent, although you will see, as I say, you will see it in the documentation. But what you need to know about is Q-mutex, Q-read-write lock, and Q-semaphore. Sorry, I'm looking for something. Okay, I thought I had something else here. I have posted in exercises, but if you Google, you will find a lady by the name of Maya Posch, M-A-Y-A, P-O-S-C-H. Have a look at her website. I have put a link in the exercises. She wrote an article many years ago on how to do Q threading correctly, and that's the way I'm showing in this example. At the time, Qt was using the way it's shown in your prescribed book by subclassing Q thread, which is wrong. Maya Posch actually wrote this article about the move to thread method being correct, which started the whole thing. And in fact, Qt subsequently changed their documentation to show the way that Maya Posch had shown to do it. So please read the article. As I say, the link is in the exercise. I think I will show it a bit further on. This is the way you must do threading. You use this move to thread method. You do not subclass QThread. So this procedure you will basically follow always in QThreads. It's actually quite straightforward now, so the best thing as usual is to actually do an example. Right, the first thing you do is declare your thread and instantiate an object of it. You then declare what's known as a worker. That's the object that's going to get moved to the thread. And just remember in Qt, your worker must inherit Q object. You can't move something to a thread if it's not a Q object. So your worker class must inherit Q object. So once you've declared your thread and declared your worker, then you call the move to thread method on the worker and you pass the thread as an argument. And that is basically all you have to do to implement Q threading. Probably the most complex part then is to connect the signals and slots. And these generally are the signals and slots that you will need to connect. The first one is optional. You connect the worker's error signal to a suitable slot where you process the error string or handle error messages. So that one is optional. It's not always used, but it's generally a good idea to handle your errors. But the important ones are you connect the thread's started signal to a slot in your worker, which it doesn't have to be called process. It can be called process or start or run or something, but that is basically where execution starts in your worker object. So you get your thread's started signal to connect to a slot, which is often called process or start or run in your worker, and that is where execution of the worker begins. You then connect the worker's finished signal to the thread's quit slot. In other words, what you're doing, you get the worker to say, right, I'm finished, I'm done. Thread, you can quit now. We finished. So you connect the worker's finished signal to the thread's quit slot. And then both the worker and the thread, you connect their finished signals to the delete later slots. Again, you're basically saying we finished. You can call delete whenever you're ready. So those are the 4 signals and slots you should always have. The thread's started signal connected to a slot in the worker that actually begins the execution of the worker. The worker's finished signal to the thread's quit slot, and then both the worker and thread's finished signal to the worker and thread delete later slots. And then you start the thread. You call the start method, and that will emit the started signal, which will then basically start the processing within the worker. So this is every time. It will never be different. You declare a Q thread, instantiate an object. You declare a worker, which must be a Q object, and instantiate an object. Move the worker to the thread, connect the signals and slots, and call the start method on the thread. That is the same every time. And that, in a nutshell, is how to use Qthread. It's not particularly difficult. You will get more difficult examples, and I will be uploading one for the exercises where you have to implement multiple threads. That does complicate it quite a bit. But this here is the basic procedure for threading. And so once you've done an example or 2, I think you'll find it's actually quite easy. But please, this part about the signals and slots, that's actually probably the most important thing to remember. It's certainly the most complicated. But if once you know these signals and slots, and I hope you can see that it's very logical the way they're connected, you shouldn't have any difficulty with threads. I'm going to now go to show you that same example in code. Okay, we had a question, Percival.
Oh yes, so I was actually I wanted to ask about the worker class. I saw it has a process method. Does that mean, is this worker class a process?
No, that's absolutely coincidental. There can be any slot in there called process or start or begin or run or anything, but that's where you initiate your worker to begin its work.
Okay, understood.
The name can be any slot. No, that process was coincidental. Okay, then looking at an example. Okay, yeah, we've got our worker class. Notice it inherits Q object. Then I've just got a public slot and it's called do work. In other words, it's not called process. And then a signal which we call result here. And in implementation, all we've done is in our do work slot is just to emit a signal. So it's a very simple little class. It's probably a bit of a trivial example. And then your client code, again, you declare your thread, you declare your worker, you use the move to thread method to move the worker to the thread. You then connect your signals and slots. Yeah, we're connecting the finished signal of the worker to the delete later method. We're connecting a start work signal. Sorry, I'm getting myself confused. To the workers do work slot, which here just emits a signal, and we're connecting workers result signal here to handle result, and then we just call start on our thread, and then later on you can stop the thread by either calling quit directly, or it's probably better to connect that quit method, quit slot to the workers finish signal. I'm not sure why I put this separate here, but it's actually better to do that as a signal and slot. But basically that's the same procedure. You declare your thread, you declare your worker, you move the worker to the thread, you connect the various signals and slots, and you call start on your thread. And that basically is how threading works. Okay, then with the past papers, this one's from October, November 2019. I'm not going to go through it now. It's actually incomplete. You've got access to the past papers. Please have a look at this one, October, November 2019. It's an example of the kind of questions you will get on threads and processes. And some of the stuff you need to do, there's some information in tutorial letter 105 you need to look at. Please do exercise 9. There is an example there on threading, including a multi-threaded and also a process. This past paper, have a look at that and other ones. And then look at that at the MyPosh link. I have posted the link in exercise 9. You can just click on it there and you'll get to a web page. And there's links there to videos and other sites that are useful as well. And then the Qt documentation for Q process, Q thread, and then there's Q mutex, Q semaphore, and the others that I mentioned. And that briefly is concurrency. As a Q process is quite easy. Q thread is a little bit more complicated, but once you get the knack of the signals and slots in particular that are required, I think you'll find it's not too difficult. But please, I encourage you to code some examples that get them running. That's the best way you'll get yourself familiar with this stuff. As far as the prescribed book is concerned, have a look at it, but don't look at the coded examples because they are obsolete, basically. Okay, are there any questions on any of this or anything else on assignment 2? No questions. Okay, guys, and if there's no further questions, we're going to end there. So if you have any questions about assignment 2, please post them on my Unisa or email them to me. You've still got a couple of days to get finished. Other than that, next class will be in 2 weeks' time on networking. Question about past recordings. They're available in the chat of the meeting. All the links are available in my Unisa in the discussion forums for each meeting. You just go into there and click on the link and you'll get, and you just have to join the meeting and open the chat and you'll find the recording there. Okay, anything else? Oh, okay, guys, and we'll see you in 2 weeks' time. Networking, cloud computing, the end of the course. Yes, that is indeed. We're nearly there.